Hi, today we're going to dissect the sheep's brain. So before we cut our brains, we're going to identify the major parts from the external part. So the first part is the cerebrum, which has the left hemisphere and the right hemisphere. Then we have the cerebellum, which is responsible for coordinating your voluntary movements. So if you were to have a damage to this part, you wouldn't be able to walk like properly. Your movement would rather be really jerky and exaggerated. And this part is the spinal cord, which is part of your brainstem as well. And we're going to identify the major four lobes. So I'm going to identify the frontal lobe and the temporal lobe. So the frontal lobe is mainly responsible for planning and making judgments. So if you have like a damage to your frontal lobe, you wouldn't be able to really plan ahead to do something. And temporal lobe is on the lateral side, so it's here. But remember that left hemisphere is responsible for your right side of your body, and right hemisphere is responsible for the left side of your body. So basically the temporal lobe on your left side would be responsible for your hearing sounds from the right side.
Also, just to add on, for the temporal lobe, it's about like the speech part. So for example, if you damage it, you may have a hard time like understanding speech, but it could also just affect the way you talk to. Okay, but I'll just do the occipital lobe, which is at the very back here. So the occipital lobe is where you get information about the visual field. So this is where, like, if you see something, the information gets received into these back parts. And if a damage is caused in the occipital lobe, what happens is that you could possibly lose your vision, or you could see hallucination. It really depends on the person. And then I think parietal lobe is about like somewhere in between here. So in the center, kind of. Parietal lobe is about like having the sense of your environment, like your position where you are. So yeah, it's like just knowing where, like the position, the environment, yeah.
And there's also the thing called sensory cortex, also known as the somatosensory cortex. It's located right behind the motor cortex, so it's located in the parietal lobe. And the sensory cortex is where you get all like the senses from the skin of your body. So if you like kind of like stimulate the somatosensory, you would actually like feel like someone tapping on your shoulder or stuff like that.
Okay, so motor cortex is like right next to the sensory cortex. The motor cortex is also about kind of like voluntary movements. So for example, if you're for the motor cortex, like if it's stimulated like on your left side of the hemisphere, it will like move your right side of the body. And also, if you get like a stroke on your motor cortex, it could like inhibit the way your moving ability, the ability for you to make movements. So yeah, we've done the external, so we can
start cutting.
You want to cut it?
Okay.
Okay.
Moisture.
Okay.
So cool.
So
I think this side is a little clean.
yeah, this side is clean. So as you can see, like I explained, there's like a left hemisphere and your right hemisphere, and mainly it's connected by your corpus callosum. It's located around here. It looks rather like an arch form, so it allows you to communicate both between the left hemisphere and the right hemisphere.
Okay, so I could talk about the thalamus, which should be this thing. So the thalamus, that's like where it controls all your sensories. Except it doesn't receive information about your scent, like smell. So everything, it's kind of like, you know, what people, I think in the textbook it mentioned that it's like the London in England, where every like, transportation has to pass through this. So what happens is that your senses, like you'll get information about your hearing, your touch, your what you see. What else is there? Your other 4 senses, and then it sends it to, like, for example, your medulla or your cerebellum, and sometimes it goes from your lower brain to your higher brain and just sends information about your senses. Anything else? And
right underneath is the so this is thalamus, and right underneath is the hypothalamus. And hypothalamus is really like important for your endocrine system, because this is where all the neural clusters that let you feel like hunger and thirst. So if you were to like not have this part of your brain, you wouldn't actually be able to feel the hunger, and you might lead yourself to things like malnutrition. And hypothalamus is also related to your pituitary gland, which she will explain later. And hypothalamus let the pituitary gland to secrete hormones and stuff like that.
So the pituitary gland should be under the hypothalamus. I think there's something under here, but either way, I think it's like around here. And the pituitary gland is usually called like the master gland of the endocrine system. So what it does is that all the hormonal like messages go through the pituitary gland, and what happens is the hypothalamus could like, you know, tell the pituitary gland whether to inhibit or release more, like the way you produce hormones. So yeah, it controls like the other endocrine systems. Yeah.
And I will explain like the brainstem. Basically, I think the midbrain is around here, and you might notice there's like 2 bumps in here, and the first part is the pons, and the second part is the medulla. And pons basically connect the medulla to your cerebellum, and what medulla does is that it allows you to like control your blood pressure and for your breathing as well. So it's really essential along with the spinal cord. So even like if you don't have like the higher regions of your brain, you would still be able to survive with your brainstem. And inside, like, you can't really see what's inside, but there is like a reticular formation. And what reticular formation does is that it controls your arousal. So if you were to have like a shock, kind of like shock to the reticular formation, for example, you might like fall into a coma. So basically it's about letting you to like stay like awake and like be conscious.
Okay, so other than that, if you kind of go to the center, so now this is the part where you can't really see, but there's going to be the hippocampus, which is like about memory. So specifically like long-term memory. It's where you process all your memory, like store them. And what happens is that if you damage your hippocampus, I believe you could have some problem like trying to form new like memory and like events. And connected to the very tip of the hippocampus is going to be the amygdala, which is also something you can't see right now. But amygdala is all about like emotions, specifically aggression and fear. So what happens is that like if a cat was like, you know, the amygdala part was shocked, some like ill-tempered cat could turn like really mellow, and yeah.
And like the amygdala and hippocampus are really placed next to each other. So that's part of the reason why like when you have like fearful experiences, you kind of get to remember it more like long-term memory than you normally do. Yeah.
Did we talk about this?
Yeah.
I think we did.
Yeah.
Yeah, okay. Should we do it?
Yeah, we can cut
like just like we want to try something.
Yeah.
So in the video, for the person, the science guy professor, what he did was that he cut like really slowly to see if he could find the hippocampus. So we'll try that, I guess.
이렇게.
No, I think it was this way.
Oh, was it?
Yeah. I mean, we always have 2 tries, but
Yeah.
he did it this way. If you do it this way, you'll able to see it like at a whole, kind of like a circular thing.
Okay.
But let me just try. This is scary. I don't think we're gonna have to do a lot more deeper.
See all the fissures. Close.
He was able to cut this really smoothly, so I don't I'm gonna see it. Let's see if what I see is. I have no idea.
Keep going. You're almost
going.
there. Closing in. Still brain. Close. Very close now. Still cortex. Okay. Maybe close to the tip of the.
Isn't it somewhere around here?
Close to it, yeah, it's right there.
So I don't know if I cut too much now. I'm scared. Do you want to try on the other side? I don't know. I can't really tell. I'm hoping it would. Could it possibly be this one? I'm not sure.
Hard to tell.
Yeah, I don't know.
I think that's all cortex still.
Yeah. Should I cut it deeper?
Keep going.
Ooh, that's. Oh, is it that one?
Ooh, yeah, okay.
I'm not sure. Like this part.
We're closing in, yeah. We're right at the fissure here.
Yeah. Is that then gonna be the hippocampus?
Let's see. Oh, yeah, it's definitely something. Ooh, I might have gone just a little far.
Okay.
Maybe, but let's see.
What should I do? Should I cut in deeper or like? I'm not sure.
Maybe try to pluck that out if you can.
This part?
Yeah, that looks like that's our limbic system. It looks like.
Mm-hmm. That's where, since the hippocampus and amygdala is probably the big system.
I think we cut the amygdala off of that, but it's there.
Yeah, something like.
Can you use this to kind of try to pull that out of there?
This thing you're trying to
Yeah, that looks like a slug. That's kind of our. Doesn't really want to come out of there.
It's kind of stuck in there, I think.
But that's it. That's
Yeah.
definitely it.
I don't know. I'm just gonna leave it here. If you want to.
If you want to cut this one like that, then you could see this, the whole circle of that one.
Like cut it like this.
Yeah.
Here.
Or you could try on this one. It's up to you.
I don't
Or
know.
this one.
You could try now.
We don't need. I don't think we don't need to film this. Have you guys done all your
Yeah,
brain
I
parts?
believe so.
We could probably stop these.
Okay.
I have one question.
Wait, we did all of them, right?
Where is it in the video right now?
They were.
Medulla,
For the
thalamus,
administration
cerebellum, hippocampus,
So this
reticular
means you
use other sources.
pituitary gland, corpus
Psych.
callosum.
When you
Amygdala,
find the
hypothalamus.
definitions
Yeah, we done it all.
symptoms, those sites all
Technically, it should be this thing, no?
in terminal format. And
I think it's about here. Like this thing.
Thank you.
I think it's this one.
Yeah, there it is. I think that's the same.
Yeah.
That's your limbic system.
Yeah. Okay.
Hit the red button.
Today's episode of Fox News' Eerie Tale, we're gonna explore Sang-min Oh, a veteran general who has a hearing loss due to the too much K-pop listening. Hi, nice to meet you. I'm Professor Edward.
Hi, we want to meet my grandfather. He is inside. Please come in. This is Hangmin Oh, a Korean War veteran with a permanent hearing loss.
My grandpa lost his hearing when he was listening to K-pop at max volume. Grandpa! Grandpa!
Because his ears are rarely functional, he couldn't determine where his daughter is. There's a slight difference on how we receive left or right side of the sound, and that's how we determine the direction of the sound. But Sangmin had none of it. Mr. O, I will call you right now, so can you determine where the sound is coming from? As Mr. O closes his eye, he has to determine whether the phone is vibrating or ringing on the top of the table or underneath the table. Our both ears detects the frequency, and because of the Doppler effect, which alters the frequency of the sound due to the distance, we can determine whether the phone is on the top of the table or down here, blah. Now, Mr. Sangmin, I will call you right now, okay?
Okay. Up on the table.
I'm sorry, Sangmin. Sounds are basically waves of consistent amplitude, which determines how loud a sound is, and the frequency, which determines a pitch of the sound. Now, how can we hear things? Well, the ear is made of three parts: the outer ear, middle ear, and the inner ear. The pinna, which is the visible part of our ear, acts as a funnel to get the sound wave into the ear. Then it runs down to auditory canal to the tympanic membrane, or should I say, eardrum. Now, looking at the middle ear, there are three bones: the hammer, the anvil, and the stirrup. The hammer and the anvil amplifies the vibration of tympanic membrane, or should I say, eardrum, while the stirrup causes the membrane to cover the opening of the inner ear to simply vibrates. Its movement is detected by nerves that send the information to the auditory cortex. And this is how science of hearing. This is where Mr. O's over window is, and this is where the cochlea, his cochlea, is located. An average person's over window set off the chain reaction to the inner ear, but Mr. O case cannot do as effectively as others. There should be more fluid surrounding the membrane around the cochlea, which is called basilia membrane.
They wanted to get a detailed scan of Sangmin's damaged ear parts, so they decided to go to a doctor.
Today, we're taking Sangmin to hospital. Getting them. While hearing has this permanent damage, there's some way to improve those damaged parts.
Sangmin not being able to hear properly also affects his balance.
Hello, this is Sangmin O. Alright, it seems like you have sensory neural hearing loss. Let me show you. So these cells here are called the hair cells, and they are responsible for detecting sound. Currently, because of listening to loud K-pop, you've lost most of your hair cells, and you can see a difference here. Especially since you're listening to high-pitched sounds, the hair cells near the oval window are damaged because of the place theory. Of course, low-pitched sounds are irrelevant because they have to do with the vibrations in the basilar membrane, which turn sounds into nerve impulses. Well, I recommend you a cochlear implant. Cochlear implant can translate sound waves to nerve impulses into the brain, which means you don't need hair cells for detecting sounds.
Well, sadly, it wasn't conduction hearing loss, which means there's an infection between middle ear and the outer ear, which could have been solved through medical processes, but this is not the case.
guys, we're gonna explain about the human brain. As you can see, the plant brain is kind of smaller than the human brain because their functions are not fully much developed. And then we'll go through the external parts, and I would explain the internal parts. Yeah.
So we'll first explain the superior view of the brain. As soon as you see the brain, you see the two hemispheres, left and right. The line here that divides the left and right hemispheres is called corpus callosum, or also called longitudinal figure. The corpus callosum connects two hemispheres and helps them send information to each other. Some people who suffer from epilepsy remove their corpus callosum by cutting it, so that they no more suffer from seizures. When the corpus callosum is removed, the two hemispheres no longer interact with each other and just play their own roles without communicating. The line here, actually, it was supposed to be like connected, but then here. It's called a transverse figure, or also called porta hepatis. It is a line that divides the cerebrum and the cerebellum. So the cerebellum is often called a small brain. Now the cerebrum or cerebral cortex can be divided into 4 lobes. The first lobe you see here at the upper part of the cerebral cortex is called the frontal lobe. The frontal lobe is in charge of processing the cognitive skills of human, such as emotional expression, language, judgment, movement, and sexual behaviors, such. So the frontal lobe is basically the control panel of our personality and communicating. The damage on the frontal lobe causes a change in personality. For example, Phineas Gage experienced a dramatic change in his personality after an iron pole went through his frontal lobe. And a person with the damage on the frontal lobe may also experience limits on their facial expressions and difficulty in interpreting his or her environment. Back of the somewhere here is the moral cortex. The main function of the moral cortex is to control the voluntary movements, including expressive language, writing, and ocular movement, meaning just like simply your movement of eye. And the back of the moral cortex, another strip, is called somatosensory cortex. The somatosensory cortex coordinates the sensory data from all over the body. It makes good use of its close proximity to parietal lobes and helps the hunters and navigators in the world full of obstacles. Here, back of the somatosensory cortex is the parietal lobe. The parietal lobe basically receives and processes sensory information from all over the body. The somatosensory cortex is said to be located within the parietal lobe and is very essential for processing the touch sensation. For instance, the somatosensory cortex identifies the location of a sensation and discriminates between the sensations such as temperature and pain. So the parietal lobe is also important for understanding the spatial orientation and for proper navigation. The damage on the parietal lobe may result in inability to identify the correct names for everyday items, inability to write or spell, impaired reading, and also inability in locating tongues and lips properly in order to speak. So, back here is the occipital lobe. The occipital lobe helps us to map the visual world, which helps both the spatial system and visual memory. And it also determines the color properties of the objects in our field of a visual field, assesses length, distance, and depth, and identifies the last one is the visual stimuli, such as particularly the familiar faces and objects. The next one is the temporal lobe, which is located at the lateral side of each hemisphere. The temporal lobes are basically are more commonly associated with processing the auditory information and for the processing of the memory. So the temporal lobes are also believed to play an important role in processing emotions, language, and certain aspects of visual perception. The dominant temporal lobe dominant temporal lobe, which is mostly located on the left side of the human brain, is involved in memorizing and understanding the language of and processing the verbal information. And the non-dominant temporal lobe is involved in processing the non-verbal information. So the damage on the temporal lobe may result in inability or difficulty to understand the spoken words, disruption in processing the information that we see and hear, and also difficulty in what was it? Difficulty in speaking. Yes.
Now I'll explain the internal sites of the lamb brain. First, I'll need to cut this in half so you guys can see the inner part. So right here, below the corpus callosum, is the thalamus, and the thalamus is important for relaying sensory information. So you could just think of it as like a center where all the sensory information is inputted, and it sends different senses to different parts of the brain where it could process the information and apply to it. For example, if you see an object, it would send the information through the eye, and when it arrives at the thalamus, it sends it to a different part of the brain where they could actually process it. And you could just think of the thalamus as a doctor diagnosing a patient with different symptoms. For example, like if you have eye problems, and you might go to the eye doctor and stuff like that. And when there's a damage in the thalamus, it could result in sensory confusion and wouldn't really get the senses into the brain properly. And below the thalamus is the hypothalamus, and the hypothalamus name is similar to the thalamus, but you know the name thalamus itself comes from a Greek language, and it's derived from the Greek language, and it means room or chamber. So yeah, and the hypothalamus is in charge of reward. You could think of it as a reward center. The hypothalamus is regulates your motivational behavior, and behaviors like thirst, hunger, and stuff like that. And it also regulates reflexes. So and you could think of it as when you're thirsty, you could drink water, and when you drink water, you could have a sense of you could feel better because the hypothalamus helps it, and that's why it's called a reward center. And if the hypothalamus is damaged, then you would really fluctuate it in appetite, as it's related to your appetite as well, and your weight would probably decrease or increase in a large amount. And below the hypothalamus is where the pituitary gland is supposed to be attached, and the pituitary gland is the master gland. You could think of it as a master gland of all the hormone secreting glands. It gets signals from the body which hormones they need, and they send out signals to the other glands telling them which hormones to release, and they produce hormones too. For example, they have like cortisol and others, but the most important hormone that they produce is the growth hormone. The growth hormone enables your body composition and your growth and metabolism. So when the pituitary gland malfunctions, then you might have problem in your height, or it could result in your draft syndrome or stuff like that. And here is the medulla. The medulla is in charge of your involuntary autonomic functions. So it's in charge of your blood pressure, your blood circulation, your breathing, and stuff like that. So without your medulla, it's also considered as the most important part of your brain, because it controls your blood circulation and blood pressure and your heart functions. And the neurosurgeons are very cautious when it comes to brain surgery because of the medulla, because if the medulla is damaged, it's really hard to treat them. And unfortunately, if the medulla gets damaged, then you wouldn't be able to rotate your head or breathe properly, so you would need life support equipment. In the temporal lobe, there is a structure called the hippocampus, and the hippocampus is really hard to see from here because it's inside of it and we have to cut through it. But the hippocampus is basically in charge of all of your long-term memories and like the location of objects or people. So the hippocampus enables you to have long-term memory and go back to your house after school. And this is the reason why we could remember people's faces and names. And when the hippocampus is damaged, the symptom of the Alzheimer's disease occurs. And the Alzheimer's disease is mainly shown in elderly people, and it's a loss of memory, and people can't usually remember even to lock the door or open the door, how to open it. So it's quite a very severe disease, but it's resulted from the damage of the hippocampus. And at the end of the hippocampus is the amygdala, and the amygdala is the part of your brain that's associated with emotions and the responses. And the amygdala is in charge of is especially in charge of fear, and from the amygdala, it's the reason why we are afraid of unknown things, because we're not familiar to it. And there was an experiment with rats. They removed the amygdala of the rats, and they didn't fear anything inside of the cage, including there was even a cat in the cage, but they showed no sign of fear towards them. So the removal of the amygdala could show how your fears are affected by the amygdala.
So right above the ventricle, this like little line here is the cerebral cortex, and again, they are the fibers that connect the two hemispheres and help them send information to each other. And before we slice the hemisphere to search for hippocampus, I'm going to cut this cerebellum into half. And again, here, there are like kind of string cheese-like fibers within the brainstem, and they're the reticular formation. The reticular formation receives information from the spinal cord, the sensory systems, and other parts of the body, and coordinate motor movement. So when the reticular formation is damaged, it is more likely that you're going to be in a coma. There was an observation of a cat and its reticular formation was damaged, and it soon lapsed into a coma. And the cerebellum, it's called the little brain, and it coordinates movement. Motor movement. So basically, it coordinates the voluntary movement, like balance and coordination and speech, so that you can have more smooth and balanced muscular activity. Now we're going to slice the brain to find the hippocampus.
Mr. Musselman, is this the hippocampus? Can you come check?
I don't think so. This is it. Isn't this the one from the 영상? The video?
맞나? 맞았으면 좋겠다.
I don't know. What if it isn't?
나 너무 많이 잘랐나 봐.
Is this?
Mm-hmm. Nice.
So here, this is the hippocampus, and we'll try to take it out from the brain.
So this is the hippocampus, like you can see.
So it helps keep the new information that you receive turned into the memory in your brain.
Yeah. And it's the reason why Alzheimer's diseases occur.
Mm-hmm. Okay. Thank you for watching.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
A sense that we first use when we are born is smell. Take a deep breath through your nose. It is your sense of smell. Smell starts when we sniff molecules from the air into our nostrils. Our nasal cavity is used to filter the air before it goes to our lungs. At the back of our nose, there is a region called the olfactory epithelium. It is a little patch of skin that is key to everything we smell, so it's very important. It has a layer of olfactory receptor cells. When odor molecules hit the back of our nose, they get stuck in a layer of mucus covering the olfactory epithelium. It is also when the signal reaches the olfactory bulb. The components necessary for detection of these odorants are categorized in the cilia of olfactory sensory neurons. Cilia look like hairs and they protrude from the olfactory receptor cells, dendritite into the mucus covering the surface of the olfactory epithelium. Anyway, after the signal travels to the mucus part, they bind to the olfactory receptor cells which fire and send signals through the olfactory tract. Finally, the signal goes up to our brain. Animals can smell better because they have way bigger olfactory epithelium than humans.
Now I'll talk about how smell and memories are related. So when the smells or chemicals come to the nose, these smells activate olfactory bulb, which starts inside the nose and runs along the bottom of the brain. Then the information passes through amygdala and hippocampus directly. Hippocampus is responsible for memory and amygdala manages emotion.
When a person tastes something while having no sense of smell, why is it that they can't taste the food as well as before? When you eat food, the taste buds on your tongue don't just react to the actual taste of food, but also the odor. In other words, it's not really the taste, but rather the flavor of the food. The flavor of the food consists of its taste, odor, temperature, texture, and etc. So if you can't smell what you're eating, you can't identify what it is. There are different types of smell disorders, and one of these is hyposmia, which is the ability of your smell is reduced, and anosmia, which is where the ability of smell is gone. In many cases, taste loss is actually just a result of smell loss, and so this can show that smell and taste are closely related to one another.
Contrary to the popular belief, the biggest organ of the body is skin. It takes about a square feet in size, and in fact, it is the fastest growing organ. It serves many important functions. For example, it prevents viruses or bacteria from entering the body. Also, skins control the temperature of the body. Well, there are three big layers of skins. The first layer is called epidermis, and this layer is visible with our eyes. They provide protection of the body. The next layer, if you go down deeper, there is a layer called dermis. Well, this is the mid layer of the skin. It has many important functions such as making oil, growing hair, and feeling things and producing sweat. The bottom layer I'm going to talk about right now is subcutaneous fat. Subcutaneous fat is the bottom layer of the skin, and this layer is important because it attaches the dermis to your muscles and bones. And it also stores fat and thereby control our body temperature because fats provide us with insulation and keep our body from getting too cold or warm.
Types of receptors. In total, there are 12 receptors. The main ones are thermoreceptors, which is stimulated by the changes in temperature. The sensory process by which different levels of heat energy in the environment and the body are detected by this. Second one is mechanoreceptors, which is stimulated by the change in pressure of movement. This enables us to detect touch, monitor the position of our muscles, bones, and joints, or also allows us to detect sounds and the motion of the body. The third one is nociceptor, which is stimulated by pain. This is also just known as pain receptor. Its free nerve endings are located all over the body, so it is the most abundant. It includes the skin, muscles, joints, bones, and internal organs. It responds to damage to the body by transmitting signals to the spinal cord and brain.
Well, when you get pain, the pain receptor cells are stimulated and then release substance P for pain. This substance P activates other neurons so that they can deliver the pain message to the brain through the spinal gates located in the spinal cord. When the pain messages arrive at the brain interprets the pain information. Depending on the pain information, the brain decides the spinal gates to open farther or close. When the spinal gates are open farther, we feel severe pain. But when the spinal gates are closed, we don't feel pain that much because the transmission of pain signals in the brain is inhibited. Then, in Johnny's case, the spinal gates were closed. Why? Good point. One important thing I like to point out is that psychological aspects matter in the brain's decision on opening or closing the gates. For example, when you feel anxiety or helplessness, it intensifies the pain while laughter, distraction, or a sense of control reduces it. That is, he could run because he was distracted from the pain by concentrating on saving himself.
Surprisingly, studies have shown that depending on your ethnicity, you will have different thresholds for pain. This is due to the fact that different cultures have different expectations for pain. There are two types of pain, visceral and somatic. Visceral pain is usually pain that is felt within the organs. It is usually caused by compressing and stretching in and around the organs and the abdominal cavity. Somatic pain, on the other hand, is the pain that is felt within the skin, muscle, tendons, or joints. Somatic pain is usually the pain you feel when you get injured. Pain is felt when the nociceptors in the area pick up sensations related to temperature, vibration, and swelling.